All right, so now we're going to look at number 2 from the 2017 exam. They give you a graph of the polar curves, r equals f of theta and r equals g of theta. So those are given 0 to pi over 2. So it's nice they tell you the interval as well, and it's shown in the graph there. Let r be the region in the first quadrant bounded by f of theta in the x-axis. S is the other region that's shown there, so the one that's between the two curves and the x-axis. So letter A says, find the area of R. So that's the one that's just within f of theta. So your formula for this, it's 1/2 r squared theta. So it's going to be 1/2 integral, and they give you the boundaries where 0 to pi. And then the f of theta, that r value is 1 plus sine of theta cosine of 2 theta. And that's squared d theta. So again, it's 1/2 r squared d theta. I don't recommend writing this out. I would just put f of theta. The only reason I wrote it out here is because I don't have these printed, and I just wanted you to be able to see it. So again, when you're taking the exam, you could just write f of theta. That's fine. I just wrote out the whole thing so you could see it when we go to type it in. And I'm struggling having to get back and forth between the tabs here because I can't see the problem and what I'm writing at the same time. All right, so this will be 1/2 and then integral from 0 to pi over 2. And then we still need to put our own parentheses. The parentheses that are shown on the calculator here are going to go around the whole thing. We still need to put our own parentheses. So it will be parentheses 1 plus sine of x. And you can put x instead of theta. You don't even need to be in polar mode. You can be if you want to be and just make it say theta, but it's not going to make a difference. It's just the variable. It's kind of like whenever there's a t and we just put x, the same idea. Right, cosine of 2x, and then close parentheses squared dx. All right, and so that is 0.648. So easy enough to set up, but again, if you type one thing wrong, it's not going to come out right. You just need to know that formula. It's 1/2 r squared d theta. All right, letter B. Let me go back to that one. Letter B, the ray theta equals k, where k is in between 0 and pi over 2, divides S into 2 regions of equal area. So now we're talking about region S as well. So be careful because that's the one that's in between the two curves. And so it's going to be like what we did here, but we're going to have to subtract them, the outside one minus the inside one. So write but do not solve an equation involving one or more integrals that's going to give you the value of k. All right, so the first one, we're going to have 1/2 integral from 0 to k. And again, this is region S. So we're going to have to do the outer curve minus the inner one. I think the outer one was G, right? Yeah. G of theta is the outside one minus F of theta is the inside one. So that would give you the area from 0 to K. And then that's going to be equal to the area from K to pi over 2. Again, we split it exactly in half. So we're going to do from 0 to K and then from K to pi over 2. And the same thing is going to go in here. So G of theta squared minus F of theta squared. D theta. So again, it said that theta equals K, split it exactly in half. So this is the area of the first half equals this is the area of the second half. So one of them is from 0 to K and one of them is from K to pi over 2. All right, let's see. For each theta on the interval 0 to pi over 2, let W of theta be the distance between the two curves. It says distance between the coordinates F of theta and G of theta. So W of theta means you're just going to have to subtract them. It's going to be G of theta minus F of theta. The distance between them, remember the R value is the radius. So that already is a distance. You just have to subtract the two of them to get the distance in between. So G minus that. So write the expression for W of theta. So that's that. Find W sub A, the average value of W theta over the interval from 0 to pi over 2. All right, this is a really roundabout way of just testing you on what an average value is. Let me just make up one real quick off to the side with like some normal numbers. Just so we can remember what an average value is before I do it with all these crazy values here. So say you had a function, let me just make it really simple. Like say you had f of x equals x squared, and it said find the average value on the interval 1 to 9. So you would do an integral from 1 to 9 for that. That's adding up all the area, but to make it an average, you have to divide by the length of the interval. So you have to put 1 over 9 minus 1 out front. It's like if I asked you to average a list of numbers, you would add them all up and then divide by how much you got. So that's what an average value is. We're just going to apply that to the context of this problem. So it said the average value on the interval 0 to pi over 2. So we're going to have integral 0 to pi over 2 of this w of theta d theta. And then out front, you're going to have to put 1 over pi over 2 minus 0. So to clean that up a little bit before we go and type it in the calculator again, it's just going to be a lot of button pushing. Getting rid of this 0 here, that's 1 over pi over 2. That would reciprocate that. So that's 2 over pi integral 0 to pi over 2 w of theta d theta. All right, so now we have the job of typing that in the calculator. So out front, we're going to have 2 over pi, and then integral from 0 to pi over 2. And then w of theta was g minus f. So let me go back to the other tab and get those. All right, so g is 2 cosine x. I'm just going to say x instead of theta. All right, so that's g, 2 cosine x, minus parentheses, because I want to put all of f in there. F was 1 plus sine of x, cosine of 2x, close the parentheses, because again, I wanted to subtract the whole thing, dx, and then that will be your answer. So 0.485 is that average value. So again, setting it up isn't bad. I just feel like typing that was an awful lot. Also, I know this because I've already worked out this problem. They have you reuse this answer in the next part. So we're going to have to store it. So hit store alpha A, enter. So store alpha A, enter, that will store it. Because as a heads up, they're going to make us reuse that in the next part of the problem. And if you cleared out your calculator, you can always get it back. Just hit the up arrow and it'll bring back what you had, and then you can store it. So part D, using the information from part C, find the value of theta for which w of theta equals that average value. So we want to set w of theta equal to this 0.485. And so again, we want to have that stored. Now they ask us for some other stuff, but let's take care of that first. We want to see where w of theta equals 0.485. So we're going to go to y equals, we're going to put w of theta into y1, and then we're going to put that 0.485 into y2 and calculate an intersection. So again, w of theta is g minus f. So g is 2 cosine of x minus f, which we want to subtract the whole thing, so parentheses around it. Parentheses 1 plus sine of x cosine of 2x. So that is our w of theta in y1, and then in y2 I'm going to put alpha a. That will copy and paste that average value that we found in part C in there for us, because we want to find where these are equal, so we want to find where they intersect. So let's go to window, let's make it 0 to pi over 2. And then I'm going to hit graph. We actually, let me go ahead and change the y's as well. We have this equal to 0.485. That's really teensy tiny. I'm going to make it -1 to 1. If we don't like that, we can always readjust it. But I'm going to start with the y's, -1 to 1, and the x is 0 to pi over 2. And then there's that average value. So here's where they intersect. We're going to calculate that. So second trace, calculate intersection. It's going to ask you first curve, second curve, yes. You can basically just hit enter for all of that because there's only one intersection. If there were two, you would just move the cursor closest to the one that you want. And it will come up. So 0.517 is what we get for that. So theta equals 0.517. And they're not done asking us questions. So just as a heads up, we're going to need to store that value as well. So I'm going to quit out of here. And if you hit X enter, it'll bring that back. So X enter, and I'm going to store that as A. I can store it as A because I'm done with the other A value I had stored. If you keep storing as A, it'll just cover up what you had before. If that makes you uncomfortable, you can store it as B. You can store it as whatever letter of the alphabet you want. But I just stored it as A, that intersection that we got, that 0.517. So the next thing they ask us here, they said, find that, and then it says, is the function W increasing or decreasing at that value? Give a reason. What we're going to do is find the derivative at that value. And if it's positive, it means the function's increasing. If it's negative, it means the function is decreasing. And so this is more fancy button pushing in here. The derivative on the calculator is math 8. We're going to go math 8, d dx, and then W of theta is going to go in there. So one more time, W of theta is G minus F. So G was 2 cosine of X minus F. I want to do the whole thing. So parentheses 1 plus sine of X cosine of 2X. And then such that, and we want the derivative at that 0.517, which I had stored as A. So I'm going to do such that alpha A to copy and paste it in there. And we get negative 0.581. And so that means that the function is decreasing at that value because the derivative is negative. So we would say W of theta is decreasing at theta equals, what was the value we plugged in? They're also similar to each other. At theta equals 0.517. Sorry, that's what we plugged in at 0.517. So function is decreasing at 0.517 because the derivative is negative there. Sorry, one was a 0.517 and the other one was a negative 0.581. They were really similar to each other. I'll almost mix them up. But theta is what we were plugging in. The result we got was negative. So the function is decreasing at this theta value because the derivative is negative.